Hello friends, welcome to EC Academy.
In this lecture, let us understand Haar transformation. Haar transformation is used for multi-resolution analysis of a digital image. So it is another technique that is used for multi-resolution analysis of digital images. Haar transformation uses simplest orthonormal wavelets. It is separable and symmetric, and it can be represented in the form of a matrix. So the Haar transformation can be represented in the form of a matrix. So we can represent Haar transformation as T is equal to HF H. Here F is n cross n image matrix, H is n cross n transformation matrix, and T is resulting n cross n matrix. Here the transformation matrix contains the Haar basic function hk of z. These functions are defined over z belongs to 0, 1 for k ranging from 0, 1, 2 up to n minus 1. Here n will be equal to 2 to the power of n. Now let us see the procedure to find the Haar transformation. First we need to find the order n by taking n is equal to log n. Then we need to find the value of p and q. Here p ranges from 0 to n minus 1. If p is equal to 0, then q will be equal to 0 or 1. And if p is not equal to 0, then q will range between 1 to z to the power of p. Then we need to find the value of k by taking the equation k is equal to z to the power of p plus q minus 1. And z will be equal to 0 by z, 1 by z, 2 by z, and so on up to n minus 1 by z. If k is equal to 0, then h naught of 0 will be equal to h00 of z, that will be equal to 1 by square root of n. Here z belongs to 0, 1. If k is not equal to 0, then hk of z will be equal to hpq of z, that will be equal to 1 by root n of 2 to the power of p by 2. If z ranges between q minus 1 divided by 2 to the power of p and q minus 1 by 2 divided by 2 to the power of p, so it will be minus 2 to the power of p by 2. If z ranges between q minus 1 divided by 2 to the power of p and q divided by 2 to the power of p, and it will be equal to 0 if z belongs to 0, 1. So for all these values, 1 by root n will be multiplied. Now for example, if we take n is equal to 2, we can find n is equal to log n, that is equal to log 2. We will get the value of n is equal to 1. For p is equal to 0, we will get q will be equal to 0 or 1. So we can find the value of k by using the equation z to the power of p plus q minus 1. When p is equal to 0 and q is equal to 0, if we substitute this value in this equation, we will get k is equal to 0. When p is equal to 0 and q is equal to 1, if we substitute those values in this equation, we will get k is equal to 1. So here we have found two values of k since n is equal to 2. If n is equal to 4, then we need to find 4 values of k. Here this table shows the different values of k for various combinations of p and q. If p is equal to 0 and q is equal to 0, k value will be equal to 0. If p is equal to 0 and q is equal to 1, k will be equal to 1. If p is equal to 1 and q is equal to 1, k value will be equal to 2. If p is equal to 1 and q is equal to 2, then k value will be equal to 3. Likewise, we can find different values of k. Now we can write Haar matrix for k is equal to 0 and k is equal to 1 and z is equal to 0 by 2 and z is equal to 1 by 2. So we can write the terms as h naught of 0 by 2, h naught of 1 by 2, h1 of 0 by 2, h1 of 1 by 2. So these terms is written based on the value of k and z. Now we need to find the values of these terms. h naught of 0 by 2 will be having the same value as h naught of 1 by 2, that is equal to 1 by root n, that is equal to 1 by root 2. So h naught of 0 by 2 will be equal to 1 by root 2, and h naught of 1 by 2 will also be equal to 1 by root 2. h1 of 0 by 2 will be equal to 2 to the power of p by 2 divided by square root of n, that is equal to 2 to the power of 0 by 2 divided by root 2. So here the value of p as well as n is substituted. So we'll get 1 by root 2. h1 of 1 by 2 will also be equal to minus 2 to the power of p by 2 divided by square root of n. Here if we substitute the value of n and p, we will get minus 2 to the power of 0 by 2 divided by root 2, that is equal to 1 by root 2. Therefore, we can write the Haar matrix as 1 by root 2, 1 by root 2, 1 by root 2 and minus 1 by root 2 by substituting the value of h0 and h1. If we take 1 by root 2 as common, we will get h2 will be equal to 1 by root 2 into 1, 1, 1 minus 1. So this is the Haar matrix for n is equal to 2. For n is equal to 4, if we do the same analysis or if we do the same calculations, we'll get this matrix. So this matrix I have directly written. So if you do the calculations as we have done, we'll get the matrix for n is equal to 4. This is about Haar transformation. I hope you have understood the topic. Thank you.